Today we're going to look at recursively defined sequences. All right, so there are a couple of standards that you need to refer to. Also, to be successful, you need to be able to write terms of recursively defined sequences. You need to be able to write a recursive rule for a sequence, and you need to be able to translate between recursive rules and explicit rules. All right, also a couple vocab that you need to be familiar with. Make sure you put these in your notes. An explicit rule gives a sub n as a function of the term's position number n in the sequence. For example, an explicit rule for an arithmetic sequence, 3, 5, 7, 9, etc., is a sub n equals 3 plus 2 times n minus 1, or a sub n equals 2n plus 1. All right, a recursive rule gives the beginning terms of a sequence and a recursive equation that tells how a sub n is related to one or more preceding terms. All right, so those are something hopefully you become familiar with. All right, key ideas: a recursive equation for an arithmetic sequence. Okay, remember, arithmetic means you add or subtract the common difference to get to the next term. So your recursive equation is a sub n equals a sub n minus 1 plus your common difference. And for a geometric sequence, your recursive equation for a geometric sequence, a sub n equals r, your common ratio, times a sub n minus 1. So you can see arithmetic, you add or subtract your common difference. Geometric, you multiply by your common ratio. Example 1. So example 1 says write the first 6 terms of each sequence, then graph each sequence. All right, A part says a sub 1, or my first term, equals 2. And this says a sub n, so this defines any term as a sub n minus 1. That means my previous term plus 3. So think about what this means instead of just looking at it as an equation that's hard to understand. If you understand the meaning, then it's going to be a lot easier. So let's look at our second term. All right, so we're defined a sub 1 is 2. That's my first term is 2. A sub n, so I'm going to say my second term is in a sub n minus 1. So 2 minus 1 is 1, so that's my first term is 2 plus 3, or 5. All right, so a sub 2 equals 5. So what does a sub 3 equal? My previous term, which now is 5, plus 3. So that's 8. A sub 4 equals my previous term, which now is 8, plus 3. See how easy that is? So 8, 9, 10, so this is 11. And then a sub 5 equals my previous term, 11 plus 3. And then my sixth term equals 14 plus 3, or 17. All right, so it says write the first 6 terms. So 1, 2, 3, 4, 5. We're given the first term. If you want to do one more, you can. I'm going to stop here because that gives us 6 terms. Then it says graph the sequence. All right, so the first term, n, is just the term. And then a sub n is on the side here. So we're just going to graph the first term is 2. So 1, 2. So this is 6. So 2 is going to be in here somewhere. All right, so then we have our second term, 2 and 5. So 2 and 5. 5 is going to be right below 6 there. All right, and then I've got my third term is 8. So my third term is 8. So 6, 9, 12. So 8 is going to be right in here somewhere. And then fourth term is 11. And then my fifth term is 14. So you can see we're adding 3 to each previous term. And then the sixth term is 17. And without plugging it in, we could do our seventh term would be 20 because we just have to add 3. All right, B part is similar. B part says a sub 1, or my first term, equals 1. And then it says a sub n is defined as 3 times my previous term. All right, so if I want to find a sub 2, I'm going to do 3 times my previous term. So my previous term would be 1. So that's going to be 3. A sub 3, I'm going to have 3 times. See, in the equation, 3 here doesn't change. 3 times my previous term. Now my previous term, my second term, is 3. So I'm just going to plug that in. 3 times 3 is 9. So now I can find a sub 4. So I'm going to have 3 times my previous term now was 9. So that's going to be 27. And then a sub 5, my fifth term, is going to be 3 times 27. 3 times 27 is 81. And let's do one more. The sixth term is 3 times the previous term. Previous term is 81. 3 times 81 is 243. All right, again, we can graph these in the very same way. So we've got first term is 1. So we're going to graph 1, 1. Okay, since this is 40 and this is 80, 1 is going to be very close to the bottom down here. We're going to do 2 and 3. It's probably not even that far up. All right, so 3 and 9. 4 and 27. 5 and 81. And 6 and 243. And these first ones, these are going to be very close to the bottom here. Since this is supposed to be 1, 1, this is going to be like almost on this. And 3, let's see, 2, 3 is going to be very close to the bottom as well. 3, 9 is not going to be much further up. And 4, 27. It's not about halfway to 40. So you can see that these are discrete points, right? So it says a study tip, a sequence is a discrete function, so the points on the graph are not connected. You can see that it kind of makes an exponential growth curve. It is going to be an exponential growth curve, but we don't connect the dots here. We just put these on here as points on a graph, discrete points on a graph. Okay, so it said write the first 6 terms. We did that. And it says graph each sequence. We did that. Example 2 says write a recursive rule for each sequence. So the first thing we have to do is look at the sequence and see if there is a pattern. We got to determine whether it's arithmetic or geometric. So negative 30 to 18 to negative 18 to negative 6 to 6 to 18. All right, so it looks like they are adding 12 each time. So if I do negative 30 plus 12, I get negative 18, plus 12 again, plus 12 again, plus 12 again. So I can see that this one's going to be arithmetic because I have a common difference of 12. All right, so then I need to remember what the sequence tells me to do. So it says a sub n equals our previous term plus our common difference. All right, so there's two things that we need to know. You have to remember with the recursive rule, you have to also define your first term. Okay, so that's a common mistake. Our first term is given, but you have to state that's your first term. So a sub 1 equals negative 30. And our recursive rule would be a sub n equals a sub n minus 1 plus 12. So this whole thing is what we need to write it down. So why do we need to write down our first term as negative 30? Because if you're going to define this by using your previous term, to find my second term, I need to know what the first term is to plug that in and write the rule. All right, B part, it does not look like I'm adding or subtracting here to get to the next term. So let's see if we can find a common ratio. Maybe this is geometric. So let's take the second term and divide it by the first term. So 100 divided by 500 is 1/5. All right, what about 20 divided by 100? That is also 1/5. 4 divided by 20 reduces to 1/5. And I'm assuming 0.8, go ahead and check it, 0.8 divided by 4 should equal 1/5. So this one's going to have a common ratio of 1/5. So this time we're going to use the geometric function instead of the arithmetic. So we're going to use the rule that states a sub n equals our ratio times our previous term. All right, so once we define that, we can also write a recursive rule the same way. We need to state our first term. Even though that's given, we need to write that a sub 1, our first term, equals 500. And a sub n equals our common ratio, in this case is 1/5, times our previous term. A sub n minus 1 just represents our previous term, because if I plugged in 2 minus 1, that becomes 1. We could take our first term, plug that in, and get our answer for our second term. All right, so that is our rule for a geometric sequence. All right, self-assessment. Which one doesn't belong? Which rule does not belong with the other three? Explain your reasoning. Pause the video, take a minute to look at these. This is a self-assessment, so you should try to do it on your own before we talk about it. All right, which one doesn't belong? Hopefully you chose the second one. If you look at these 4 rules, you'll see that 3 of them are recursive rules, and the second one is the only one that is an explicit rule.